Hey, what's up guys? Mr. Fabella here. Today we're doing another lesson on changing dimensions. So what that is if a new rectangle has twice the length and twice the width of the original rectangle, how would the perimeters and areas compare? So think about it. Let's take a look at this. We have an original rectangle here, a 3x4 rectangle. What would happen, let's think about the perimeter first. What would happen if the perimeter doubled if it was a 6x8 rectangle? So the new one would be 6x8 like that. So then let's calculate the perimeter. The perimeter is 2 times the length plus 2 times the width, right? So 2 times 3 plus 2 times 4, that's going to give us 14 units. For the new one, it's going to be 2 times 6 plus 2 times 8. That's actually going to give us 28. Think about that. How do those compare? So if you're thinking you just double the perimeter, then you're exactly right. So let's take a look at some examples for perimeter first, and then we'll come back around to think about area. So suppose the side lengths of a parallelogram at the right have tripled. What effect would this have on the perimeter? So this one, we're talking about a 3x4 parallelogram, then it tripled. So 3 times 3 is 9, 4 times 3 is 12. So let's see what would happen. Okay, so if I find the perimeter of the original, that would be twice the length plus twice the width. So 2 times 3 plus 2 times 4, which gives us 6 plus 8, which is 14 inches. The perimeter of the new one, it would be similar. 2 times 9 plus 2 times 12. That gives us 18 plus 24, which is 42 inches. And so that's not exactly what it's asking. It's asking, what effect would this have on the perimeter? So the effect would be, the perimeter would be multiplied by 3. Good. And you actually didn't have to find the perimeter of that. You just had to know, okay, if you're talking about perimeter, that's a one-dimensional change, or that's a one-dimensional measure. If each of the dimensions is multiplied by 3, then the entire perimeter is going to be multiplied by 3 as well. Okay, another example here would be, suppose the size of a pentagon that's 8 by 8 by 8 by 8 by 8 are multiplied by 1/4. What effect would this have on the perimeter? You probably already have an idea of what effect it would have, but let's just make sure. So this is a regular pentagon, so a little bit of new vocabulary there. Regular means all the sides are equal. So kind of like a square is a regular rectangle, or a regular parallelogram, or a regular quadrilateral. This is a regular pentagon. Anyway, so the perimeter is going to be 8 plus 8 plus 8 plus 8 plus 8. But the shortcut of that would be 5 times 8. So that would be 40 inches. So what effect would this have on the perimeter? So let's see if I can draw. Okay, I tried to draw a pentagon there. That's, well, see. Multiplied by 1/4. So let's make sure we know what we're talking about here. 8 times 1/4. This is 8 over 1 equals 1 over 4. That would equal 8 over 4, which reduces to 2. So this would be a pentagon with 2 by 2 by 2 by 2 by 2 inches. The perimeter of the new pentagon would be 5 times 2, which is 10 inches. What effect would this have on the perimeter? You would say the perimeter, I should just type this. I'll just type this down. It was 40 and then it became 10. So if you were in a rush or something, you might say it's 4 times that. No, it's not 4 times that, because you're going from the original, which is 40, down to 10. So the new perimeter is going to be 1/4 of the original perimeter. Maybe you're thinking, hey, Mr. Fabella, this is way too easy. This is just perimeter. Let's get on to the better stuff, the harder stuff. Exactly. So we're going to go and talk about area now. Hey, check this out. This is still here. We have the perimeter, and if it's multiplied by 2, then the perimeter is multiplied by 2 as well. Let's see what happens to the area though. So area of a rectangle is length times width, right? So length times width here, 3 times 4, that's going to be 12 square units, okay? Length times width, 6 times 8, that's going to be 48 square units. That's not double. So you have to be very careful when you're just guessing, oh yeah, the area is going to double too. It's actually not. So this is actually times 4. So the dimension, this is one-dimensional. If you're talking about the perimeter, it's just one-dimensional. If it's the area, that's actually two-dimensional. Not only is the length multiplied by 2, but the width multiplies by 2 as well. So if it's times 2, you're actually going to have to square that multiplication factor. So if that's kind of hard to tell, just take a look at this right here, right? That's a 3 by 4 rectangle. So I can actually split this up. This is 3 right here, and this is 4, right? I can actually put this rectangle in this rectangle. So now it's kind of easier to see what's happening to the area, like how much space is inside there. Because if you just say times 2, well, if I multiply the length by 2, and it's just 8, then it's times 2. But then I also have to multiply by the width by 2, so that increases by 2. So check it out. I have 1, 2, 3, 4 of the same rectangles there. And that's because whatever I multiply by, I'm multiplying the length and the width. So that's why it's squared. So if it's twice as long, it's twice as long on the length, twice as long on the width. So I'm multiplying times 2 twice. So if it was 3 times, it would actually be 3 times as long here, 3 times as wide here. That would be 9 times, because 3 times and then times 3 times 3 is 9. So whatever the factor is, it's going to be that factor squared. So let's see if that works out in our new examples. So it says here, the side lengths of the triangle at the right are multiplied by 5. What effect would this have on the area? Justify your answer. So we're going to actually solve these first. I'm going to guess that it's times 25. Okay, that's what I'm going to guess. But let's see if that's correct. So recall, so I'm going to make this the green triangle, and I'll keep this as the blue triangle. All right, so the green triangle, area of that one, area of a triangle is 1/2 base times height. 1/2 of 1 times 2 is just 1 square centimeter. Let's do the blue one. Area of the rectangle or triangle is 1/2 base times height. 1/2 times 5. 1/2 times 10 times 5 is 25 square centimeters. Then, as you can see here, I guessed correctly. The question was, what effect would this have on your area? It would multiply it by 5. And that's my justification right there. And the reason why is because it's multiplied by 5, right? 5, and then you square it, because 5 this way as well. So 5 to the second power is 25. So 5 times 5 is 25. Okay, so this is a little more challenging, but I know you're up to it. Stop sign is in the shape of a regular octagon, but don't worry, you're not going to have to find the area of that. Sign A at the right has an area of 309 square inches. What is the area of sign B? What we recalled is whatever the multiplication factor is, how much bigger it's getting or smaller it's getting, for area, you take that number and you square it. And that's what the new one's going to be. So let's find out. How do you get from 8 to 12? So if that's not automatically obvious, you can actually find that out by taking 12, that's what you started off with, and dividing it by 8. So if you do that, so if you get that, it's 1.5. So stop sign B is 1.5 times larger than stop sign A. Okay, so that we can work with that. So it's 1.5 squared times the area. Okay, so let's work over here. So it's going to be 1.5 squared. So what does 1.5 squared mean? That means 1.5 times 1.5. So if I do that, it's going to be 2.25. Okay, so 2.25, that's how much bigger stop sign B will be. So let's kind of try to organize this out here. All right, so in that case, stop sign A is shown at the right, has an area of 309 square inches. So let's kind of organize this. So first I found the scale factor. Second, I found scale factor squared. And then now I'm going to take the scale factor and I'm going to multiply it by 309 square units. Okay, so I'm going to multiply 309 times 2.25. Okay, so I have 695.25, and this is in square inches. So a lot of steps, but that's what you have to do to find the new one. Okay, so last example here. The area of the small trapezoid shown below is 6 square millimeters. What is the area of the second trapezoid? So don't worry, we're not going to have to find the area of these trapezoids, even though it's 1/2 base 1 plus base 2 times height, if you forgot. But what we're going to do is follow the steps we did before. First, we're going to find the scale factor. So scale factor, we're going to find that by dividing the 2. So how do you get from 2 to 10? This is a little more obvious. It's 5 times. Part B, what's 5 squared? 5 squared is going to be 25. Part C now, it already says that the area of the small trapezoid is 6 square millimeters. What is the area of the second trapezoid? So all we need to do here is take 6 millimeters and multiply it by 25. So that's going to be 150 square millimeters. And you can kind of see, like, not all of these are drawn to scale, but you can see that, yeah, 6 millimeters, 6 little squares can fit in this one, and 150 little 1 millimeter by 1 millimeter squares can fit in the bigger one. So that's why it's going to raise up by that much. The perimeter, it would only increase by a multiplication factor of 5. So if the perimeter of this was like 10, the perimeter of this would be 50 or something. Maybe in the future, we'll revisit this and talk about what happens when you take the side length of a rectangular prism, a 3-dimensional shape, and double it. What do you think is going to happen to the volume of a rectangular prism that has a side length twice that of the original? Think about it. Maybe put in the comments or something. But yeah, we might come back to that later on. So I hope this was helpful, and I will see you guys next time. Bye.